Hi, this is Richard Collins, and I just wanted to show you something that I was working on today. IRIS, Incorporated Research Institutions for Seismology, IRIS.edu, has data on many things, and here's an example of a station that I'm looking at in Albuquerque. It's the default one. When you go in to do searches, they say, well, here's an example, ANMO, Albuquerque. So now the problem here for programming is that all of this stuff is scattered all over, so you have to kind of tease out what's going on. Particularly what I'm running into is there's not documentation readily available just to go in and know immediately. The data does not come down in standard units, it comes down in machine units. Well, that's a convenience for them, but it's a real pain if you're trying to consolidate and organize all of this. I'm looking at the meteorological data right now, and it's kind of a mixture of things. Infrasound actually is a meteorological data, and all of these do. I mean, even seismometers to some degree, there's coupling between the Earth and the atmosphere, and I presume, at least for infrasound, it would couple. So, magnetic field definitely is interesting. Anyway, I'm trying to connect. Actually, I'm trying to correct the superconducting gravimeter data for meteorological changes, and I'm trying to check the radiation balances in the atmospheric models that don't want to get anyway. All right, so where do I find this stuff and how do I get it? So I was looking at LDO, which you have to memorize all these crazy units. LDO. There's two of them in here. Actually, there's 11. These two are current. You see that there's no expiration date on that. So I'm looking for current data, and this is actually from 2012. So this has been fairly stable for quite a few years. Let me go down and see what else there. This is an older one that they had, which is not operational now. It went up to 2018. So pretty much you have a thing. Now, this is all human in the loop. So, they dump this out. A human has to read it. And presumably you're supposed to, manually transcribe it back into programs. So it's not really a data set. So ideally, this whole page would be in a JSON of some sort. But even more than that, it needs to be in a management system so that you can actually do things. Let's go on down. That's current. So there's a lower quality chip sensor in the Cetra box. So there's an LDO is, well, actually it's really hard to find. I've been making notes and searching. Meteorological sensors, some of these are mentioned in here. And so the transportable array, read. And down in the middle here is this table in HTML, which isn't very useful. So, the units are stuck in here. The conversion is implicit. A human has to read it and do the conversion. So this is the samples per second. That's nice. These are the channels. The instrument is actually not very clear because Vaisala, I think that's how you pronounce it, seems to have a number of things. So that whatever their current product name is, you can't get to the model. Well, it's not real clear anyway. All right, so I'm trying to get LDO, just this absolute barometric pressure. So now there's a time series thing in here. So this is let's go back there. So there's 30 LDO. Let's go back again. 35 LDO. That's an older one. Okay. So here's a 31. I'm writing these down because I have to remember. 31, 50, And 31 is CIPS, PAS, by Sala for 50, by Sala. This is not current. I'm going to look in July this year. This is at 30, which is Cetra, 30, Cetra, whatever Cetra is, sensor, wherever that is. Okay, so presumably I would, again, by human eyeball, trace it out. If it were proper, you would just go and hover over this and then tell you exactly, where it was for your context. Let's see on down. Oh, well, here's some, let's see, these are instruments. So, that's earlier. Okay, so so these are the earlier instruments. So if I have to go back, then I'll need to read this whole history of everything. And again, it's not in a database, so I have to do it. There's a lot of repetition in here. A lot of hard to read stuff. I can't, this is nearly impossible for me to read. It's that on a blue background. These light color, this is a very lightweight font. It's hard to, unless it's bolder, I can't see it hardly. It strains my eyes just to death. Okay, so it looks like there are 3 LDOs. So I'm working on, let me close that. I'm working in Notepad, and I have a little background script, a content script that I wrote, and I just started this thing, get iris data. So place equals, well, I'm having to transcribe this stuff here, so that is, I can close, well, I'm going to leave this meteorological sensor thing open. It's just, okay, so here's metadata, this is this one. Okay, I need these 3 because I want to calculate the height. I'm going to use the elevation in meters for the atmosphere, because presumably that's basically that's a permanent height. I mean, if you're in absolute units, that's supposed to be where it is. Now, the gravity changes over the year because of the sun and moon slightly, and the atmosphere is sloshing around doing its thing. But ultimately, that's sort of a constant in here that I might be able to use. So let's see. Okay, so now, where's my crazy program again? Okay, so r dot, let's just put that in here. Latitude is equal to, well, at least it's decimal. The only problem is this implicitly is this way, is 34 north. Okay, 35 north angular degrees, and you can't separate it there. So if I'm doing this properly, that's one way to, r dot longitude is equal to, now the minus sign I finally learned, it's westward from westward. That's now you can go either way. The minus in there, you see it, you say, oh, well, that means westward, or do you put it in as that and say westward? Do I change it from the original? Okay. And I think here I'm just gonna I don't know. It's westward, and again that's angular degrees. Degrees, and those are plural. Okay, so which one? Okay, r dot elevation is equal to quote. Basically, I'm going to use a parser, text storage, and 1820 meters. Let's see, westward angular north, and the direction. I see. Elevation is vertical meters, vertical upward. There's an implicit direction in here, okay? Vertical upward meters, okay? That's a little hokey, but I'm just going to stick it in there. All right, so at least that gets it in. Now the place is Albuquerque, so I'm just going to New Mexico, and let's see, I lost my page again. Let's go to here, Albuquerque, New Mexico. And actually, you may think this is weird, but the proper way is this way, USA, New Mexico. Actually, it's New Mexico. All right, one more time. Kentucky. Search Albuquerque, New Mexico, county. Now, if you do as much genealogy as I do, you know you need to know Bernalillo County. Okay, so let's get back to this thing here again. Okay, so I could say country, USA, city, Albuquerque, state, New Mexico, county, Bernalillo, and that would work. So I'm not happy with it, but I could do it. I don't want to type equals. I don't want to put quotes and weird things in there. I just want the basic information. So this one could have been done that way as well. So I could have put in this could have been north latitude, latitude, and that in angular degrees, like that. Let's see. So do I parse? Do I leave it in human form? Do I? I don't know. You need to keep it together, and you need. So most all of these are vectors. A huge amount of this stuff is in vector. There's an implicit direction in there, north, lat, long, and height, or they're anyway. So let me just keep going. I just want to get this. I'm not going to use these at the moment. I'm just starting it. Okay. In the URL here, I'm going to take the IU and replace it with the r.network. Okay. So I'm planning ahead that I'm going to substitute into here the things I want to change. So change. Now, I'm going to leave the example, change ANMO to r dot station. So here I'm just changing it back to a self-loaded station. I want to run this online and just be able to specify it. I can't quite do that because I don't have an interactive way to enter data while I'm in a content script. But then I can fake it and say, look, while I'm in here, let me go grab that data and parse it and all. The results are. Let me show you what it's going to look like when I run this. So here, I need the location and the channel. Okay, so let's stick. I keep losing my thing. R dot locate sensor location is actually sensor ID. Sensor. I'll just leave it location. I don't like it because it implies a physical. It is probably a physical location, and that is. Let's just use 31 is what the r dot sensor equals LDO, and those that correspond. So that here they call it channel, but instead of sensor. So I'll use their language here. I hate not having to change the name, the words for every single context that I'm in. Okay, so here's Control C. So the sensor location, I'll do it there. Okay, location there. This is going to be locate, where's the damn location? IU station. Oh, loc equal. Okay. Now, is there any extra loc in there? Probably. I'll say ampersand loc if I wanted to. R station, ampersand loc. Oh. No. Okay. So, change 31. Okay. To R dot location. And fiddle faddle, Control C, here, channel, change LDO to channel. Okay. Then what? Data. Let's see. Our text equals. I think it's just called get by URL. I have dozens of names for grabbing a page off the web. I want the HTTP version because I'm in the content script and I have local permission to read things if I'm inside the content script. So get URL, give a URL, and I'll check that in a moment to make sure that. And once I have it, I have to. What does it look like? It's gonna come down as. Let's just run it, and then I'll know what it looks like. So here I got this. So click in there. It does open a new tab, thankfully, and it has these horrible name. They convert to day number in here, so you can't, unless you memorize the day numbers and dates of everything in there, you can't actually locate this. So, oh, this was for July. I need the date. I need to change the date as well. So this was July. I see 2020 0701 by seconds. Okay, this and this one is I think it's that one. So you lose context here unless the human has to memorize from the time you're going back there to here, or you keep it out there and then it comes into your human eyeball, then you have to go back out again. So this is always a wasteful step in here, and it's always incomplete because I don't have time to go in and copy these names out so I can sync my data here with that. So I make it so I can read it later and understand what it is. I don't want to memorize, LDS, LWS, anyway. So let's just save that. Yeah, go ahead and replace it, and then I'll just. I'm in the middle of editing it, so let's see what the data looks like in here. So this is what the data looks like. It's a 2-column format that I chose, and then I don't know the units in here I don't know what these numbers are at this point. This is LDO, and it doesn't say. This is 31 LDO, so IU and MO 31 LDO. It's consistent once you've memorized all that, but it's a pain in the buns to use it. All right, so I need to get the date in the proper format. I want to change the month in here, and the day. So the month, I'm gonna year, month, and day. I'll need to do, and then I'm gonna just set this for. It's horrible. I'm having to go in and write a little thing just to set the, just transcribe the settings into the proper format. I need it in a human form so I can automate it. But once automated, anyway. So it's the usual. Okay, so year, month, day, and that. So back to here. So I also know, r dot start date, and I'm working against this. So the start date is this longish thing, and actually this is just the start date. Now here I'm gonna have to. These are different. Okay, so at least they're sufficiently different. I can use them there. So start date equals, and I'm going to leave the time on here as so the start date is 2000, like this. Control C, R dot end date equals. And I'm going to make that 02. So it's 24 hours. I just terminate there. I didn't go figure out, well, what's the end of the day and that kind of thing for the end of the year. So control. Now, I could do these and then concatenate together, which is a pain. I'm trying to do this like a human would. You would take a sample and do it. So whichever way. It's all horrible, I think. So, all right. So our channel, these might be a little bit easier to read if I do this. All right. So let's keep going. And this one is going to be this one. Date, Control C, and that means with R dot start date. Believe it or not, this is more efficient than some things. I mean, at least I'm not spending, even longer just trying to get the doggone thing to work. That's 02. And end date. All right. How am I doing? So save that, and as a text, I don't even remember. It's so hard. I can't find the example because I don't know the name. I don't remember what library it's in. I have so many hundreds of files with programs I've written. I think by URL. Let's see, search, find in files, and it comes on the other side. I'll just say URL. And it's going to search here, and it's just going to go through these. So let's see, URL, get file, HTTP. So that's the thing that I use. Control C. Okay, so all right, so close that. So get file HTTP. That's at least one. Okay, so, and then as it's in this format, so I want to split it by. I don't know if it's going to be carriage return line feed or line feed carriage return. So let's do that. Var lines equals text dot split. Let's do one of these, and how do I do it? It's going to be /r/n, so more things, or /n globally. That's a little overkill. I think that works. I have to go look that up every time. It's one or the other. So let's see, what's the next thing I do for the lines? and then the first line has the label, which I'm going to skip over, and then go through here to the end here and read the date and time. Okay, so let's see if I can get that done, and I can split this on a space. It would be much better if they would do tab separation, but they don't seem to understand, or maybe it is. I don't know. Let me see if I can find that. So let's get that. Let's go to here. Oh, show, cancel, showing. Let's see. I have to go back to here. Show in folder. So, and it comes up over there. All right. Come on, people. Okay, so here's the one that I did. Edit with Notepad, and it comes up on the other screen, of course, and then turn on this. So those are two spaces. Okay, so that, and then you have no control over that. You can't say, well, look, I want the damn thing with tabs in here. You know, actually, I want it in JSON or something else. Okay, yeah, because I like the year, month, and day, or I'd like that text string and say that's my date and things like that. All right, so let's just keep going. So Albuquerque, my program is where? Here. Okay, so equals 0 through, or is actually equal to 1 there. I less than lines dot count I plus. At least I've memorized this and done it a few hundreds of thousands of times. Certainly 10,000s of times. Okay, lines. If, oh, see, our line equal lines of I, if not line, continue, the usual crap you have to do. Let's see what else. Okay. Bar fields equals line dot split two spaces. Okay. And here for a single day, you know, what do I have? There's not a way. There's not an easy way to convert. There's not a date conversion routine. Let's see. Let's see. Date. Let's see. Start. Let's see. Year equals. Let's see. Date text equals fields 0. The first one. Year equals date text dot sub. Let's see. Substring of 0, 2. Back to counting characters again. Year, month equals that's worst. Let's see, 2020 year is a 4-digit year. 5, 6 for a length of 2. I don't know if I'm going to use these or not. I'm just sticking them in. Control C. These are getting. I'll just do it this way. Tab. Day is 3 more, 9. So that gets me there. Oh, and the time, that's what hour equal substring. I'm reading from here, so I'm out to this. So if you look down here, it's 15. So this is column. It doesn't say where I'm at. So you have to highlight it. Okay, so that one highlights to there, and it says that's 15. So it's 15 to 15 to hour min. I better write it out. Minute. Equals. This is going to be 3 more, so it should be 18 to seconds. And these are all in text still, so I got to seconds. I don't know, hour, minute, second. Okay, let's date text. Okay, so it's here, and it says 18. So, and that's going to be for a length of that many. Okay, and that's a length of 9. What did I just say? 15, 18, let's see, day, hour, minute. Oh, this is terrible. Let's see, not that one. Let's close that. Where's my other? Okay, so this one was out to 15, and this is 18. Hour, minute, second. So the second starts at 18. Okay, so just minimize that. Minimize that. Hour was not that. So hour was 12. Minute was at 15. That's at 18, and that was the length of 9. Now those all have to be converted to parse float, parse int. They need to be changed in if I'm going to use them. So, all right. Well, that gives me, and then let's put the records. I'm just going to stick in here. Var record rex equals. Actually, I'll put them in an array. So, oh, and this is that's fields third text. So var rec equals this. Can you guess? I've done this a few times, and it's still, you have to make up things each time. Here. But parsing these out into, so you can identify each one. And ideally, you need to, now minute is minute, they basically, they're, the names are telling you the units, and so you're managing the unit by putting the name on it, but then anyway. All right, so rec, and then rex dot push rec, and then just say return. I'm not going to do anything. I'm just going to try to run this and see if it parses and get that far. So I should be able to see that. Oh, and what's the date? The rec dot data. What's the name of this damn thing? I don't know. And here, this just reads it, and it's just a single column equals fields of 1. Okay, so let's see if I can get. And I don't. And then the problem is I probably should need to put in what units. Okay, so and then LDO R dot. Let's see, R dot units equals LDO. See, 10 Pascal. 10 pascals. Okay, what each count in there corresponds to 10 pascals. I'm pretty sure that's correct, but I don't know for sure. I have to do this, go look at the data, run a bunch of things, and see if it makes any sense. And so I could do that and keep it, the first record in there, I could actually shove in. It doesn't really matter what the record is, what's in the first record. So I could put, let's see, Rex, okay, and then just say here, just Rex dot push on the first one, R. So the information in here can go in and let's just do the R dot URL equals URL, okay. And then I should say request for URL. So I'm going to shove that into the first record just so I keep track of it. It's dumb to have to do that, but and then this one, that's probably right. I need to 10 anyway. All right, this is getting long. So I got it there. It should be able to work. So I've saved it. I have to go to the extensions and find the one I'm working on. This is it, reloaded. Now this page here, see, it's actually the URL builder. Yeah, this is the one. And I could be anywhere. I can be on here, for instance. Okay, so if this works, I should be able to come in and reload that page and there and get IRIS data. Let's turn on the and put it over here on the docket to the side here. There. Okay, nothing network. Go to the sources, and I need to go to the constant here and my view of the page here. You see how many things I've written, and that's just not even hardly a scrap of the stuff that I need or use overall. Okay, so here it got that in there, and when I push the button, it'll come into here. So if all right, so that's the URL, and let's see. So the let's keep going. All right, so the record that I've got, that's the stuff that I'm shoving in the first record. Okay, so that's easy enough to do. And I think actually not that, something on this order is probably, basically it says you need a human language parser when you transmit stuff this way. If you're going to communicate with somebody, you tell them everything that's there. And now you could say, well, everybody knows latitude, and there's a universal resolver for latitude, and that our current standard is there. And then you say, well, and just latitude standard. You maybe that's all you have, just standard latitude, something like that. I don't know. All right, so it gets there. Okay, so I got that. There's my rec. So the first record is gonna be that one. Okay, it's just basically I'm following the same. It's an array of records. So the first line becomes a record, and they can be as complex as you want. It's just a little bit easier to work with. Let's pray and hope that this actually is able to read that thing, and that I formed it. Let's look at the URL, and you can't. It won't. Damn. Okay. All right. So time series, IU station and mode channel LDO start is there. End equals that. Format equals ASCII. Location equals 31. That looks right. Let's see if it's able to do it. Pray there. Okay, so it actually got the text. So some things, I mean, if I had toolkits, so split the lines. So now we've got that many lines, 86,402, which means that there was an extra carriage return at the end down there. Let's look and see. That's why if you look at the thing, you see there it is. There's an empty line at the end. And that's just because the thing terminated with a carriage return. So, and that's why I check if there is no line, all right, let's just go down to here. I'm going to assume that I'm able to actually just walk through it. Okay, so, it blew up. I made a mistake. Okay, so what happened here? Let's close that. See lines lines dot. It's not lines. It's not count. It's lines dot length. Damn. Okay, so I'm changing count to length. I'm not tired that I can forget something I've used a million, not quite a million times, tens of thousands of times. Probably isn't that right? Okay, so what did I do? I changed this to length and saved it. Then I have to go to the extensions and reload it. I have to go to the page I'm working on and reload that. Okay, and then here I should be able to go in and say get that and not follow through, but it'll stop it when I get down to here. Run that. And there, okay, now so the lines all that. So the first line is there. The fields are split on the thing, so it should be two of them. Yeah, that came in. All right, so date fields, rec, year, month, day, hour, minute, second, and data. And so the data was it got the seconds it got. I'm not sure. I think there's supposed to be 2 zeros there. And the month is off, and that's off. So the minute's off. So it looks like it's zero base, so I should have gone there. So that the data looks right. Let's see if I can, instead of there. So I need to drop all the numbers down by 1, and that'll bring it there. And I think this may not be, well, I don't know, we'll see. And then year came out fine. It was the first one, but it's all the rest of them are off by, zero. There. All right, so the months should be 5. This one will be 8. This one will be 10. This one will be 14. That one will be 17. Save it. Got it saved. Extension, reload. Page, reload. And let's stop here and get the data. And so there's the record. And okay, so the seconds is kind of funky. I don't know if it, and that's screwed up. The hour's wrong. So I the minute there. So hour, day 1, T0. So my hour is still wrong, and I need So the hour's picking up a T, so I need to make it smaller yet again. So this was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The T's in 10. So how many are out there? That's 8. So that 8 needs to be a 7. That's what's wrong. Just stupid counting characters again. Save that. Go back here. Go to the extensions, reload it. Go to here, reload that. And then it's gonna, I didn't run that again, or did I? Okay. And then I'm getting the same day again. Pardon me for using this stuff. So there's my record. And oh, I still got the hour wrong. Did it not reset this? I reloaded that. The day's wrong. Okay, I got the day wrong. So the day needs to be day needs to be 8. Okay, so the day was wrong. Day needs to be 8. Hour needs to be one more. That needs to be back to 11. Oh, you probably saw this, and then you just minute and second. So the hour was off. So I got those. These two should be fixed. They're okay. So I don't care. Let's just. I want to run through the list just to see that it's doing it there. So the recs are here. Let's just pick a random somewhere in the middle there. So there's that. So the data, and okay, so it's doing its job. I just got to, that'll get corrected. Now, what do I want to do with these? I actually want to count. I want to count the values. That's my main thing. So let me do that real quick. So. Rex here are counts equals that data. I'll put it in here. Counts plural. This is going to be rec.data. Okay. So I'll see. Okay, so let's do that. I'm not going to count the total yet. Actually, I can stick it in here. Where is it? r.url is that here. Let's stick this in. r.line count. Let's say lines length equals lines dot length. That's dumb. But constantly just say, how do I memorize this in this context? How, and then it's only, you only need it long enough for you to get the job done, and then you forget it. Okay, so I did that. I saved it. I got that. Let's go to the extensions and reload it. Let's go to here and reload it. And okay, so it did that. All right, so it's going to count that, and if I have 4 or 5 or 50 counters. That probably fits what the most recent version. So we'll see if it actually does it, and then get the data in there. So counts. It's going to be large. It's waiting. Is empty. I may have to look. Oh, there it is. Okay, shoot. Okay, I knew. Okay. Okay, this is actually an important concept here. Okay, so this is the range in here. So this is a variable, and there's actually not that many. So it did all of those. It counted them. Where are all my numbers? Okay, so they're all scattered out. How many? and I should have put a count. It's hard. One of the things when you do it this way, it's very fast and efficient. Okay, so we have 86,400, and then these values. I don't know what these units are. So this is LDO. It's supposed to be atmospheric pressure, I thought. LDO. And but I anyway. So I counted what was in there, but I have no idea what it is yet. So let's see this. So once I have it, then I can like collapse it to something, like do bins that are small enough where I can see them. And actually, let's see what on the counts. If I was going to save this, do I want to save the raw data and the counts? It depends on the context. When I'm testing, I save everything, or I'd like to have it available so I don't have to go back in and do it again and again. So I'm sort of stuck here. What I was thinking, I'd like to know how many that's how many records there are, but how many unique values were there? So how long was that counting array? Let's see if I can fix that one more. Let's see, how many are there? I want to know. I hate this because it's really ugly. Our categories are unique values is equal to counts dot, no, what's the syntax? It's object dot keys of counts dot length. I think that is object dot keys dot count. Let's see if I can find object dot keys. Copy that. Go to here. Object dot keys here, and of the object, and so dot length. It should be okay. All right. So downloads. I don't need that there. I'm done with that one. Back to see. I saved my program. Where am I? Where's my program? Here. No, I didn't save my program. So there. Now reload this. That's one. Reload this. And that's just to help me. There. Okay, so unique value. Yeah, 29,781. So 86,400. I got that many unique values for that. So it's a fine-grained number, but it there. So now I can do the mean and standard deviation and convert everything into z-scores, which is the range from the thing. Or I could take and bracket them and order them, and then mark them according to like deciles or something like that. It's hard. I mean, generally what I've been doing is just use the whole thing, and not for human consumption. I want to see something. There's only so many categories. I want to cluster or group them so there are fewer things to remember. But in the computer, it doesn't matter. The big deal is I don't know what the doggone units are for this one, and so I'm going to have to build a database of all the units and conversions and do that. Anyway, that's where I'm at. So that was supposed to be. This was 31 LDO, and in my in here, let's close that there, and in here wherever 31 LDO is. That one, this pressure sensor, let's see if there's this channel summary, it just CPUS, so it's supposed to be running. It tells me where it is, what sample rate it is. So I got the data. I just don't know what units this pressure is in. Oh, now let me look at those numbers again. Whoops, atmospheric pressure. Okay, so standard atmosphere, Pascal, Pascal bar, torr, inches of mercury is what I think they did. Where's the damn, pardon me, where's the thing? What was in that field? Let's see, here. Oh, well, okay, 174. I can't see anything. It's supposed to be, O means outdoors. LDO is supposed to be atmospheric pressure according to this. And then, but this is some thing, 174. Now there could be a conversion in there, like convert this to, to make this 1 atmosphere, 100, if this were Pascal, or tenths of pascals. There. So all right, how do I find it? I've been searching all over the web trying to find these guys. So this is CIA PAS pressure sensor. Let's see, it's out here. It says absolute pressure sensor. And it's either, I don't think it's in torr. I mean, I think could be Pascal, kilopascal, or Pascal. Let's see. This should show up. There were 2 million channel descriptions. So this is just one of those stations there. Anto. Oh, pressure in pascals. Oh crap. All right, it's going to do that. Show in folder. Edit with Notepad. It's going to be an XML. Crap. Latitude, longitude. These things might be useful. You can get some of that data in these different forms. You just have to know where to go to look for it. ASL web service, Caribbean, Control F, LVO. See if that's going to find it. Close. Latitude, continuous weather, azimuth, depth. So it's actually going to get to the point for all the sensors, I'm going to need to know their orientation because I'm using them for imaging. I'm actually to the point where I'm starting to look at that. So pressure in pascals. That's what it says, but that doesn't. The atmospheric pressure is it's the outdoor absolute pressure. Digital counts. Input units, pressure there. Frequency. Oh, here's 31. That's 30, 31. Let's see if they use it. That's the same pressure in pascals. Okay, so 8,000 to there, some kind of a coefficient or conversion. So let's try this. Okay. I need to check there, here, 31, correction, apply. Let's try let's plot this out so I can see what it looks like. Okay. Oh, it says Pascal. Okay. So they did a correction on that. So if I convert this, do an instrument correction on this, convert it to this, and then look at the data, I should be able to convert them into the right thing. So let me regress the converted values against the raw values and extract their instrument data. Poof, I don't want to do that. Okay, so this is a ASCII 2 column. I'll leave it that way. Actually, I only need 1 column because all the date times were in there. Okay, so this will generate that location there. And I said this time perform instrument correction. So that means do the calibration. And then there, and this is Pascal's. Save it. Open it. Okay. Here. Okay, 815. That seems really weird. Okay. It should, Envo, are they, they're not, maybe it's way up on the top of a mountain or something. See, 100,000, yeah, 100,000, 101, 325 is the atmospheric pressure there. So they're up at so many thousand, they're up at 1,000 meters. So they're up at, so all right, so that's the converted values. Okay, so let's get this thing, Control A, Control C. Go into Excel. Go back to this one. Cancel. This one. Oh, sorry, wrong one. This is I'm doing another experiment here. Let me wait till. See, here's what I'm plotting out all these things here. I'm having to do it in Excel because there's no toolkit. So I got that in the clipboard still. Let's get back to Excel. Let's just do that one. That's the calibrated one. Put in a few blank lines because I might need the space at the top. Let's see what else I need. I need, come on. I need to go back to here. That one, try again. Here. And this was the one, and that was the calibrated one. This is the raw one. By saying CI path, open, edit with Notepad. And it keeps going. Okay, this is getting Control C. There. Back to Excel. Here we'll get that. I can put 2 of them in there. And then this I need to split. Here's my split thing. Next. Space. Yeah. Okay. And consecutives double there. Finish. Okay. So there. Now I got the time in here. Goes over there. So I got the time date. Oh. Let's move this up to the, missed it. There. Okay, and this one, I'll move that up to here. Okay, so this is pascals, and this is counts, or raw volts, or who knows what damn units it's in. Counts probably. Let's see, I need to correlate these somehow. Let's see, how do I best, let's just stick them in there. So the pascals, they should be exactly the same. They should all convert. Okay, I'll do it this way. I know so many different ways. So take the counts and the, okay. So let's do a pivot table next. Next, existing sheet. Let's put it there. So I'm going to take the count and do the pascals in here. And these, it says sum, either, and I'm going to do the average for those, okay? Stupid, isn't it? Okay, so so that's, okay, you have an in and you have an out. Do I want to write a do I want to do a regression for it? No, I can just do a lookup table. So, I mean, it's stupid, but it worked. And now how many unique values were there in here? So this is that same 29,700 some odd. So all those unique values in here, that's from the horse's mouth. That's from the source. I just let them do the conversion and said, you tell me what it is. Now, where I can, I'll ask them from here on. I'll say, go and do. But I might, I've done a bunch of instrument corrections, like go in and say, look, I don't believe this particular instrument's working that way. That was the whole point of doing, calibrating the superconducting gravimeters and all the seismometers, is their numbers aren't quite right. You say, no, I'm putting it in a global network. It can't work the same way as if you're just running one. Okay. All right. Let's do what else? So I've got those. That gives me a unique list, and then I can take these guys here. Control C. Put it here. Control V, and this is count. So I took all the counts and all the converted values, and then Pascal. And that makes sense. That actually fits what I did there, and it must be. I'll have to look at the height, in the atmosphere. Yeah. So I've got those two, and I should be able to show the here. Yes. Okay. So let's look at the regression for this. Add a trend line, and just linear. They just used a linear. So show the equation and the R squared. Okay. And then here, this damn hard to see. Okay. Just blow this up. View, zoom to 150%. Okay, now we can see a little better. And this one, okay, that's not very helpful. If maybe it's right. That doesn't look anything like that other one, but that would, no, it should be there. Let's see. Let's do one, format the trend label. Let's go to scientific notation, and let's make it 6 decimals. You have to click somewhere else. Okay, close this, get the pascals out of here. Okay, so that was more, so that 1, 2, 3 became there. That's hard to read, so I don't. Let's try it again. right click, format trend line label, and let's just do it in number format, and again use 6 decimals. Click somewhere else so it'll apply it, close it, and now we've got that 1227. All right. So that's it's probably supposed to be 60,000, but let's take this thing here, Control C. Let's put it in here. Okay, there's the top one. Control X here. Oops, Control Z. There. There. All right. Stick another one in here. Insert. Take this estimated. Here the estimation is my version of it. So it's that plus that F4 twice, that F4 twice times counts. And we'll look at the delta in here and just see if, I'm just curious about that. X, end up, Control C, down, end down, Control V. All right, so I can use that conversion for this instrument and all. So now I can read the things off of there. I could probably do the regression from counts to calibrated in there and recover the instrument stuff if I have to. And these residual and plus that minus. I generally subtract the estimated. And so these are all going to be off because of the rounding. They just used a few decimals, I think. So, and that line fits for all these. So end down, X, end up, Control C, end down, Control B. Okay, end down. I don't know if you care about this stuff. Let's go to smaller. Why is it didn't? It should have allowed me to change the format of that. There it goes. Control C, end down, paste special, formats. There. Okay, now I've got the whole all the clunky things you have to do to get this to work. Okay, now they're all over the place. See, I think 462929. This is not 44. I think that they're not the thing. Anyway, so that sort of works. I mean, there, so I can, on that particular instrument, then I can do that, or I can just tell it, like on the put it wherever I can, have it go apply the instrument thing. But some of them are missing. The Visela stuff looks like all of them are in raw units. I didn't see. Actually, it said 10. Maybe, let me try that again. Let's do that. Maybe I just missed something here. Okay, I'm allow myself to make mistakes. So 50 was the Visela version of this, and let's do the instrument correction on that one and run that as a plot and see Pascal. Okay. That looks ugly, doesn't it? Oh, they use a really coarse grain thing. This is just a cheapo thing. So times 10 to the 4th. Okay. All right. So it corrected it. So it did that, even though the instrument thing came in. So I wrote to those guys and asked them, I said, what are your units? And I couldn't tell what they were doing. It was me not being familiar with the way the data was stored in there. So I can basically do that and get it in the correct unit. So, okay, so then I just have to, so those are Pascal. So I basically need to run each one of these this way, look at the units and see, and that's over time. So pressure goes up, pressure goes down, pressure goes up. This is colder, right? So pressure's lowest. Oh, actually, this is in, one more time. So the pressure, the atmospheric pressure this is at midnight this is UTC, right? So this has got to be midnight at, where am I? Midnight at meridian, at the what is it in England? Where the prime meridian, right? So okay, so that's midnight there. So in local time, or are these? No, these are in UTC. What did that thing say? It didn't say. Okay, they didn't say what time units this was in. So you can't tell from, if somebody just sends you, oh, well, here, I generated the data and sent it to you, you don't know what you got. Okay. So LDOM, that's interesting. They put that name on there. So it's not just LDO, it's LDOM. And these are local times. I think they're 6 hours behind. So that would be, so this is midnight. So 6 hours, 6 hours back, 6 hours back. So it's 6 o'clock, 6 p.m. there. So this 6 p.m. Okay, it's getting colder, colder, colder. This would be earliest in the morning, and then the pressure drops as the temperature rises. That's what's going on. So this is in the evening. The pressure's high, relatively high from the day. Okay, through the day, it gets highest, and then it gets cold. So this is coldest. So if I do the temperature for this, then I can recover their model of the atmosphere. So I should be able to go in and basically take each of the temperature, pressure, take all their readings and generate the model that they're using inside for converting the thing. I don't know, when you convert, you need an equation of state for the gas, for the real gas. I don't know what units they used in there. So ideally, the model for inside the instrument, in the research group, what they did and how they calibrated and how they did their stuff, and the actual calibrations of the instrument would be in the instrument, and they'd be universally available. Whether it is wherever you are in the world, whatever place you're at, wherever computer or system you're in, you can just simply trace through and say, show me the instrument model and what they're using. What constants and values and models did they use inside what they're when they generated this stream of data? Was it validated? When was it checked last? That kind of stuff. All right, so I think I got this. I just talking this out helped a little bit. I solved one problem here. I don't have to worry about the units. I'll just apply the instrument calibration, what they call it, to perform instrument correction. So I'll let it do that, and I just have to change my thing here. Oh, correct equals true. Okay, so I need to add that into my, no, that was the wrong one. That into my program. correct equals true. Okay, so that's a, and then the units are, there's no way, it's not going to tell me the units, I think, or is it? When I ran that on the Pascal, it'll be on the first line. Okay, so the units are not there. So I think I'll have to parse that header and see if I can recover this shit out of the header, or this part of the units is coming out because it's magical. Okay, I say correct true, and it just says, go do your thing, and then tell me what it is. So when in that thing that's coming in here, oh, that's it. Okay, that ugly thing there, you're supposed to go in, and at the end here it says PA, and you're supposed to know that means Pascal, and then that's where the units are. Now this is arbitrary, so you don't even know, there's no field names, there's nothing in there. If you send it as an array of records, then you could break it out and say, look, here's the station, here's the network, here's the station, here's the location of the sensor ID, and this is the LDOD. This is how many samples, that's the sampling rate. Here's the year, month, day, start, hour, minute, seconds, and decimal. S-list, I have no idea what that means. Float probably applies to this. And simple list is the format. So that the S-list has to do with, did you put the date none? So it's in there. It's just you gotta go pull it off. All right, let me stop here. So I did find this thing in there, and it kind of did it, but it didn't really tell me, because what I needed was the conversions. And actually that one wasn't clear, because it didn't tell me, here's the equation we use to do the conversion. And you need that, because if it's wrong, I want to know it. I'm trying to use these things down to the nth, for things you can't even imagine. So probably people who do this every day could, but I'm surprised. Let's see what I can do. If you have a parcel of air in the atmosphere, it's at a given temperature, and its density, and if there's wind in it. Okay, so because of its temperature, it has an absolute radiation field. So it acts as a black body, which is an ideal photon gas mixed with molecules of air. And because of that, it acts the partial pressure of the photons can be calculated. It's the energy density. So the energy density, the radiation energy density, is the power, the Stefan-Boltzmann power from the fourth power of the temperature, and then that gets divided by the speed of light to give you an absolute energy density. The energy density is in pascals. It's a partial pressure of the photons from the fact that those infrared frequency range has particular energy, but that's only the infrared. It's not all things. Like the X-rays are just floating right on through. They don't even stop. Long waves and everything else, microwaves and radio waves that are in there, which could have tremendous power. Some of the low power things are really, it basically spikes at zero frequency. It goes infinite at zero frequency, which is all your background background, basically what I call the radiation field. The high frequency stuff, if you can't track the phase of it, it comes through and just mushes out, and all you get is a constant value from it. So I'm sorting that out. I have to sort that out to distinguish between gravitational signals, magnetic signals, electric signals, electromagnetic, which where you can, it's a packet or there, radiation, like hard radiation, particles, cosmic rays, all the kinds of, zoo of particles and things that are out there. I can sort it out. I checked every single damn one of the models and the things. And now I want to put them all in one calibrated system. So, the radiation intensity matches the atmospheric radiation partial pressure matches exactly the signal that needs to be corrected in the gravimeters. And if you can do that, then you just stick in a radiation sensor and you just correct your gravimeter. It's there basically. The point of me doing these optical sensors is I can measure the noise in sort of an independent way, basically independent of the antenna shape roughly, and correct it. So basically I can say, look, here's the radiation field, here's the gravitational part of it. What it is, it's the gravity is the sun and moon signal is the diurnal variation in the Earth's radiation field. The Earth's radiation field includes the usual radio signals like we do, but it also includes the potential change underneath, which is the gravitational part. So it's all one field. That's it. All right, well, I just wanted to show you what I was facing there, and let's see, what else do I need to do? So I got that, I got this, let's move these. Okay, so we're, yeah, there's that thing. I think I'm good. Just for my own purposes, I'd like to know what they're doing on each of these. I'd like to get, and maybe I can find the instrument correction. Let's see if there is and save that. Okay, so I corrected now it's say corrected equals true. I like those. Okay. That's this one. That's just there. See if he had pressure. I was going out and trying to search it. A lot of this stuff, I memorized this stuff 30, 40 years ago. I mean, I went through the U.S. standard atmosphere in the 70s and 80s again. So, I mean, when it came out, the most recent one, I wrote the Fortran, converted it to Turbo Pascal, did a spreadsheet version of it, checked every single piece of it carefully. Then in the 80s, when the global climate change came, then I went through all that again to check and see, okay, what are they doing in their climate models and all so. All right, so here I was looking at this channel LDO. I think this is going to show me. Down. No, it didn't. Where the heck is it? I thought there was that's a channel summary. How do I get to, I thought it gave me the calibration on this thing. That's that guy. Let's go back. Oh, actually here. So it doesn't say 31, like this one. Let's see, data available, restriction, that's their LDO. I thought I found there's a thing, there's a search that gives you the instrument response. So this one, this definitely should have the units, and if there's an equation, it should put it, oh, here it is, okay. Wrong one. Okay, so that's in this form. Counts, longitude, and sample rate, Pascal. Okay, and so zeros and poles. So that's sort of there. That doesn't tell me. Let's go back. So, here's the response. Okay. Oh, okay. Look, there it is. Okay. All right, I like it. Okay, see what that was the number in the spreadsheet. Okay, these two here, I was able to recover those and see them, and they're in here. So I have to read this damn thing to learn what it is. So end time there, and the reason it does all of that query. So that's just going to a different one. I think what I want to do is pull this out. Okay, I want to take this number. So, end time, that's for the whole instrument. The whole instrument. Actually, I can take for the time that it's in there, the start time and end time, that would work. Okay, so if I take the basically leave the start time, end time for that, change the beginning of this, and stick it in and get this out. Parse this damn thing because it's going to be in text. And okay, that gives me lower portion about digital count. Okay, P transfer. I don't know what that is. P polynomial. I bet you that's what that stands for. And it doesn't say stage sequence. Polynomial coefficients. That's a label. And you just have to read it. Number of coefficients. Okay, 2. It's actually not the number of parameters or parameterization. Numbers. The number of numbers in the parameterization is that, because that's a constant. They're actually value to the 0. Okay, so I guess that's the way they're doing. All right, I can do that. So take this thing here, Control C. What am I doing? I need my program here. Control V. Bar response URL equals quote there. And the start time and end time part, I'll just have to break that out and do it. It looks like I need to change time series query IRIS.edu time response and theirs. I just need to change /1 2 2. So these are going to be the same. So the response URL. So that's here. That's the text. Our response text equals response URL. I'll do it. That'll get it. And then this one, basically, it's just you get the damn there. Okay, is URL dot replace replace time series. It looks like they're pretty consistent. It's kind of neat in a way. Okay, so now I got that. I should be able to go and read that. This is getting long. Let me stop here. Just curious if it actually was able to do it. The extensions, that would reload that. Any of these should work. So if I here, let's reload that to be sure. It can be anywhere. F12 to get that over here. Let's see if this response text is that. Get iris data. Here's the response URL, looks fine. And did it blow? It blew up. Okay, so apparently it didn't like what I. So. It's the I need to replace that out. All right, one more time. I'm almost there. So what am I doing? I'm just going to take that, and after I built the URL, rect URL, response text there. Okay, that's that one. So there. God, I hate all this typing. Okay, so that'll get the correct one in there, and then in the counts are here, and I'm going to do it this way. R.response text. I'll stick that in there for now. I'll just put it in the header. Basically, I'll put it in that first record. Response text is that. And actually, I'm going to put the response, this one, R.response URL, R.response URL. So everything, basically, I'm just storing everything over there. So R.URL is that one there. That should work. Let's see if I get this. So extensions, reload, this one, reload. There, what happened? Maybe I got a typo. Shit. Something's going on. So here, content scripts didn't get loaded. There. Something. Check my program. Let's see. That looks okay. These are okay. Didn't do anything weird there. That's R.response text. R's in there. R.response URL equals that. R URL. RX push. That looks fine. So everything's saved. This one is reloaded. This one, stop it and restart it. There it goes. Okay. Oh, and now it's back. So something got fiddled in here, and now it's reloaded. I must have caught it in the middle, or just did something stupid. Okay. And now here, the one last thing. This is running long. I'm sorry. It should have read both of those, and it blew up. So send IRIS.edu. I'll check those things separately. So there's something. Shouldn't block me from going. Oh, is it? Oh, it won't let me go to the response. Oh, response 1 services. IRIS.ws response 1. I might have a typo in there or something. I'll just have to go fiddle that. Okay. So IRIS.ws. They're RESP1. Maybe they're server. I don't know what's going on. Did I type that? No, oh, I missed a slash. Okay, that I missed the slash on that. All right, how we go? Save that. Reload that. Reload this. One last try. Okay. And that went through really fast. Oh, so that was their response. Is in here. Oh, that's URL. Response text is there, and there's my numbers. So okay, I just had a typo, and then let's see here. Go to there, and then unique value is 29,781. That matches what I got before. The Brex are the counts are there. That's a really ugly thing. They don't count the size of it, they should look ahead. Okay, so there's a wreck and there's all my wrecks. Okay, so I got it. Let me stop here. Thanks for listening.